So let's look at what we call the law of magnetism. So the law of magnetism, it states that like poles repel each other and unlike poles attract each other. So meaning that if you have a North Pole and a North Pole close to each other, or a South Pole and a South Pole close to each other, these poles will repel because they are like. But if you have a North Pole and a South Pole close to each other, these two here, they are going to attract since they are unlike poles. So whenever stating this law, please, it is one law. Most people tend to separate it into two, which is not okay. State it as one law. Like poles repel and unlike poles attract each other. That is the law of magnetism, or what sometimes we call the fundamental law of magnetism. So we had talked about polarity of a magnet this side, and basically we said polarity, it relates to the poles of a magnet, and we also define the poles of a magnet. So let's look at how we can test for polarity of a magnet, meaning that how do you determine whether the pole of a magnet, how do we determine whether the pole of a magnet is a north pole, or how do you know that the pole is a south pole? So that is what we call testing for polarity of a magnet. So to test for polarity of a magnet, we need to have a magnet whose poles are known. So assuming we have two magnets, so we need to first have this magnet whose poles are known, and then we also have another magnet whose poles are not known. So we need to determine the poles of this other magnet here. So this one, for magnet A, for magnet A, we don't know its poles. For magnet B, its poles are known. So to determine the poles of this magnet, the only sure test that we can use is the repulsion test, because according to the law of magnetism, like poles repel and unlike poles attract. So we use a sure test, which is the repulsion test, because you can test for attraction and repulsion. So the only sure test that we do is called the repulsion test. So we don't use the attraction test, because if this, let's say if you bring this close to this and it attracts it, you can deduce two things, because it can attract a magnetic material, it can also attract a magnet. So the only sure test is the repulsion test, because if this pole repels this one, it means that they are of the same polarity, or this would be a similar pole to this one. So basically what we do is that a known pole of a magnet is brought near the ends of a magnet with unknown poles. So meaning that you bring this pole close to this other pole of this magnet whose poles we don't know. So if repulsion occurs, then that end of a magnet is a like pole. So if this pole repels this other pole of a magnet, if these two repel each other, it implies that this pole is similar to this, since according to the law of magnetism, like poles repel and unlike poles attract. So we don't conclude on the attraction. Because attraction can either mean the poles are unlike, or it can mean that this may not be a magnet, but it can also be a magnetic material. Because magnets attract magnetic materials, and it can also attract another magnet if it is an unlike pole. So that's why we don't conclude for the attraction, but we only use the repulsion test as the only sure test. So we have the results in this table here, which we can use whenever we are testing the poles of a magnet. So for example, these ones are these poles here. For example, if for this other magnet whose poles are known is brought to the other magnet which we are testing, and there is repulsion, then it means that the other magnet has a north pole So if you bring a south pole to this other magnet and there is attraction, then it can either mean it is a south pole or it is a magnetic substance. So we don't conclude on this. So the only sure test that we conclude is the repulsion test, this one and this one. So you easily make a conclusion when the poles repel each other. So we don't use attraction because it means two things. It can mean the pole is opposite, because you can see attraction can either mean the pole is opposite, or it can mean that the other substance is a magnetic substance. That's why we don't use it.